Maybe before we get started, I'll just have my friends also introduce themselves.
Sure, I'll get started. Thanks, Nouman. Hello, everyone. Really happy to be here. My name is Aditi, and I serve Thoughtworks as a technical principal, specializing in enterprise modernization, platforms, and cloud. Yeah, that's a full mouthful. But yeah, basically, I work with clients to work and deliver value in an iterative manner, but with a strong focus on DevOps principles and modernization strategies. In my past 8 years, I've been a full-stack developer, more recently transitioning into infrastructure engineer, as well as a tech lead and security consultant. Today, I'll add on more to what Gab and Ankit, my colleagues, also from EMPC, have shared with you around engineering platforms and platform engineering in the context of developer efficiency. So really nice to be here and looking forward to the discussion. Thank you.
Hello, everyone. I'm May, Head of Technology for Southeast Asia. So as part of my job, I actually help define the regional tech strategy for Sowmya, as well as advising client is also part of my job. Just a challenging tech excellence for us as a Sowmya brand, tech brand in here. So my passion is really around look at my job in Sowmya. I've been with Sowmya for 12 years. Has been almost just helping organizations scale. So it's really looking about how do we leverage technology to connect people, process, to achieve sustainable business outcome. So that's really my focus. So if you're passionate about a tech strategy, architecture, technology governance, so we can certainly have a talk after that. So today I actually will be here representing a low-code platform. So we'll have a discussion about this. Thank you.
Cool. Thank you, May. I thought Rashi will actually ask you to do some exercises because this post-lunch slot is so tricky. Anyways, I think hoping that you're energized. I'm Sowmya and I lead the data and AI service line for Thoughtworks Southeast Asia. Been in the industry for about 14 years now, predominantly starting with exchange trading platforms, performance engineering, been in the big data platform space for close to 9 years now. I'm working across sectors on data strategy. I'm part of the SG Tech Digital Trust chapter that looks at establishing Singapore as a global node of digital trust, and I lead the privacy enhancing tech work group as part of it. Very passionate to solve social issues using data and to bridge the diversity gap in data and AI. So you need to bear with my sore throat a bit, and thanks for that. Yeah.
Thank you. You sound awesome. Okay, when I was hearing the keynote, it just felt like a rush, how far we want to go back in the history. And it was at the beginning of internet, and I thought, let me go slightly more behind. Do you know what this thing is? Pyramid. Of course, yeah, it's the Great Pyramid of Giza. It was built and constructed many, many years ago, 4,500 years ago. It's interesting to know that these pyramids were built for these divine rulers of the land so that when they die, they're mummified and they're kept inside this gigantic monument. It's also interesting to understand there is this religious belief that when this divine rulers die, they take the afterlife journey. And it is required, their physical body needs to be placed into a massive, grand, and secured place for making that transition smoother. A lot of requirement and a lot of beliefs. Why are we talking about pyramids? How is this related to the topic? Any guess? Okay. So if you think about engineering effectiveness talks about optimizing your resources, optimizing your process practices in order to reduce waste so that your organization, teams, or engineers can be more effective. It's as simple as that. We've heard Gabriel talk about it in the morning. Now what you see on the screen is a fine art of engineering. And if you look at the history of engineering effectiveness, it goes back to the ancient engineering. It's not a new thing. It looks like a new thing because everyone is talking about it, but it started way back at the ancient era. There was massive requirement of waste control for a project like this. Think about optimizing labor, water supply, materials, equipments, and so on. The people back then couldn't just afford wasting all of that. The strict timelines. It wasn't much of technology back then, but people still build tools and automation. Things like ramps and levers were built back then to transport huge stones and get that elevation and help them be more effective. Engineers also use things like trigonometric principle that we kind of studied back in the school, never understood what it means, but they used back then to achieve some of the non-functional requirement, let me put it that way, to make it more secure for this divine soul to rest. There was this religious belief of certain angle of sun needs to be fulfilled. It needs to be more resilient to different climate condition so that it withstand for ages. All of these are requirements that needs to be fulfilled, and principles were used to kind of just fulfill all of that. Now I can go on and make it more interesting. Let's come back to software. Fast forward, not so fast, but 19th century, 18th and 19th century, industrial revolution, lot of machines and factories, promoting mass production, reducing waste, standardizing, optimizing, being more effective. Fast forward, mid 20th century, again, a lot of interesting things happened. One of the interesting things was Six Sigma. I don't know how many of you have heard about Six Sigma. Things that came into manufacturing, it was more towards quality management methodology that was applied across domain, including software. And Six Sigma principles kind of focuses on improving the software product and also making the overall development process more refined through a very data-centric approach and continuous improvement. There is this another methodology that kind of start rising up from Toyota production. Like it's always famous and comes up in a lot of engineering discussion. The lean principles that showed up again had the same aim of eliminating waste, streamlining processes, being more effective. Before lunch, Ankit talked a lot about DevOps. Now, if you try to track when was this term kind of coined, it's very hard to know what was the start. There's no start date. But what you'll find is there is this longest running movement, called as the DevOps movement, happened during the same era of start to mid 20th century. Now, I'll not get into the crux of how DevOps as a word was butchered over the period of time. But the interesting thing is that this movement started promoting a lot of software engineering practices to make the developers more effective. Things like continuous integration, test-driven development, or test automation in general, version control. The cross-functional team started, the term started getting coined back then. Again, maybe I'll just take a pause here. If you look at the evolution of engineering effectiveness from ancient engineering to manufacturing to software, you'll see there were different approaches that came in, and every approach brought in tools and techniques and methods, etc. But the objective of the engineering effectiveness has not changed. It's still the same. It is to optimize the process, resources, and practices, reduce waste so that your organization, engineering team, developers become more effective. And that is precisely the topic of our discussion today is we'll look at we'll look at 3 of the trending approaches, which is engineering platform, which Ankit also talked before lunch, low-code platform, and Gen AI or generative AI, let me be more respectful. And then we'll look at different ways how these approaches can be leveraged to unlock engineering effectiveness and make the software engineering team and software developer more effective. Enough of me talking. Maybe what I'll do is, as the next step, I'll just hand it over to my fellow panelists, and maybe if you can introduce the approach and maybe draw a lineage to engineering effectiveness. Maybe we can start with you, Aditi.
Sure, thanks, Nouman. Thanks for the history lesson. And yeah, I mean, as I was saying, like engineering platforms is something that both my colleagues Gab and Ankit have touched upon. So I'm hoping that in this discussion, I can add another sort of perspective and layers to it. Also, you know, some of the things that we've been thinking about. But just to start, maybe let's start to think about, you know, what a developer sort of focuses their day-to-day activities on. So I would say like we as developers spend a lot of time finding information in our day job, like what API to use, how do I get my infrastructure provisioned, what are the security practices I should be applying, and you know, a lot of time is spent in that. Secondly, we also spend a lot of time trying to figure out how do we productionize our software. Now that I've written the code, how does this go into production? How am I going to make sure it's resilient? You know, the right kind of monitoring is in place. And lastly, we have to join a lot of meetings where we are trying to coordinate with, you know, other teams on basically unblocking ourselves. So this is how a usual day looks like. Oh, and yeah, we still have to write the features that we have to deliver into production, right? So to me, it feels like today a developer with the DevOps practices, as well as what all is expected with the cross-functional teams, is expected to do it all. Right? To me, it sounds like we are superheroes, which I like, but at the same time, we do not have the fancy cape or the gadgets to help us in this journey. And I think for me, engineering platform is like one such gadget that we can give our superheroes to make their lives easier. So the way we define or think about engineering platform, like you know, Ankit and Gab have already talked about, is something that makes life of developers easier by hiding away the complexity that does not directly contribute to business value, and by hiding that away and making it available in a self-service, autonomous manner. So I think the key difference with engineering platform and the new thought process is that we do not request for tickets, we do not wait for support teams to get back to us, but we establish more machine-to-machine and code interfaces for us to do our job. So there are three building blocks typically when we talk about engineering platform. The first one is a delivery infrastructure hub, which Ankit elaborated in a lot more detail around requesting for infrastructure, getting your database provisioned, making sure pipelines are in place, you have security built in. But there are other aspects of engineering platforms as well. Second one that we think about are knowledge hubs. So in a big organization, it is typically important that we make the right information available to anyone who needs it. And in terms of best practices tutorials, we make that available via the knowledge hub. And the last building block of engineering platform is around a services hub. So these are common capabilities like an API gateway or an event hub that, again, all developers need to be able to deliver what they are trying to do. And the other layer that engineering platform adds to these three building blocks is like a single pane of glass in terms of a developer portal. So for example, Backstage by Spotify, which is another thing that Ankit touched upon, is one such tool that enables you to basically orchestrate and get access to all of these three building blocks. So anyone who has not worked with Backstage before, like it's the way you configure it, it can be very powerful. With like one click, you can deploy a service with your base code, with a hardened database, with your pipelines, as well as monitoring in place, right? So it takes away all of that work that you need to do to just get started. So I think in summary, I would just say that when you think about engineering platforms, like its key customers are internal. It could be your developers, it could be your executives, it could be your managers. And its main job is to make their life easier. Yeah, with that, I'll probably hand over to May.
Yeah.
All right. Thanks, Aditi. I actually think for like engineering effectiveness, right, it's not something new. So it's everlasting topic for a long time, ever since the creation of computers. So if we're looking into that, why do we looking at engineering effectiveness? It's actually just one goal, right? It's not changing, it's just reducing cost, because building software is expensive. So if we look into like our effort in trying to addressing that basically like our approach can be categorized into two directions. One direction is looking into how can we widen the talent pool. So if we look into where do we start from programming language, right? I'm not sure how many of us have like ever written an assembly language. Like that's where we get started. Great. So assembly language, they've come into like COBOL, Fortran. I think then we come to C language, right? And then we start to have Python, like a Java, JavaScript. And now English is also becoming a programming language, right? So all the effort, evolution in this space is really looking to say, how can we widen the talent pool? Just enable people, not only those people like who are special trained to become developers. So like how can we widen this entire pool? The second effort, I think the direction we're all looking to is really like, how can we write less code? So it's basically like to say, as long as you create code, you create expense because you need to maintain that. So there's costs around that. So if we look into that, I think Thoughtworks has always been an advocate of writing less code. If you are familiar with our like a core engineering practice around sensible default, you will know actually simplicity is one of our core engineering like a value around this. So then we're looking into like to say why we are talking about low-code platform. We'll start from there. So there are 3 patterns as right now in the industry talking about how do we write less code. So the first one, like in the like a customized software world, we build everything from the scratch. So like Yagni is a key principle from code, like extreme programming. We're looking to say, do not build additional stuff, just you are predicting that it's going to, for something is going to happen in the future. You only build what you say today, right? Nothing else. So that's really the key principle, what we're using to say, write less code. The second pattern that we heard is actually what Aditi just described around like build by creating an engineering platform, so that be able to enable the entire organization will be able to reuse that rather than everyone creating your own wheel, reinventing your own wheel around that one. The third option is really around, we have to talk about the rising of around low-code platform. But before we talk about that, I actually want just, I won't be able to see people raise hand, but I'll ask this question anyway, because I want to validate one of the data I'm seeing from Gartner. How many of you, so if your organization are using like at least one low-code platform, can you raise your hand, please? All right, great. Yeah, let me share one number with you. So Gartner actually reported, say, by 2024, 75% of large enterprise are going to adopt at least 4 low-code platform system. So this is a number that is like what is happening there. But whenever we starting, like we know, like for technology industry, we like to overload terms. So whenever we have a term like we have agile, we overload that, and people just like give it different meanings, and we start to debate, like to say it's no longer what we want, and like agile is dead. Then we talk about start with DevOps, and we start to overload that with just like relabeling that. It's no difference actually to low-code platform. So once this concept is coming up, I think we start to see vendors actually apply that label to the old legacy core system to say, hey, this is your like low-code platform. So I think we just have to realize, so it's a gray area. Just be don't just accept when people to say my product is the low-code platform. When they say it, just be cautious about that. So now let me just quickly introduce a key characteristic of a low-code platform. How do we know one product, whether it's a low-code platform or not, right? So low-code platform is really like a Lego. So it's like Legos for software development. So one of the key characteristics is around, like I say, it enables non-technical people be able to build applications. Like even not only just simple applications, they might be able to build certain like complex applications with some like, so that is one around like to say, it's really somehow like democratizing like to say who can do the work, who can build the work. For business actually not all like to say, if my tech team does not have capacity, they now have the developer calls what they normally call like a citizen developers to help them build the application. The second key characteristic is really around how do you build the application. It's normally drawn in a very visual way, so you can just drag and drop and just create that connection. So you build so you can build the system. So the only way is when we talk talk about local system is sometimes you might need a bit of like a customized code to make it really work. So, but normally like that should be minimized. So that's really my definition around low code I'm going to use today. All right, I'll hand over to Sowmya.
I usually feel this low code is a devil which comes with different name, like after every year, like this low code started, with a different name of BPM, IBM BPM, where you say that, okay, the business will start developing system and then enterprise service bus and so on. But for sure, we're talking about the more modern low code platform. I'll just hand it over to you, Sowmya, if you can quickly just introduce the topic.
Cool. So I'm very honored to talk about the cool kid in the block, generative AI. So maybe I'll start out with a question. How many of you have already started to use ChatGPT, Copilot, Bard in your day-to-day work?
Everyone.
Wow. Nice, nice. I actually wanted to generate my content based on ChatGPT, but I've kept it purely manual for today's panel. So before we do Gen AI and talk about why Gen AI in software development, I think it's important to distinguish between traditional AI and Gen AI. So traditional AI has been there for decades, right? And we talk about specific problem spaces. You go to Amazon or Shopee, they know your preferences, they personalize it for you. A classic traditional AI problem, right? You have your email inbox, and you distinguish between a spam or a non-spam. Classic classification algorithm that runs. You want to predict tomorrow it's going to rain or not? A prediction that runs, right? These are all traditional AI examples with specific problem spaces. Now, why is Gen AI such a hype, and it has a lot of potential, right? So Gen AI is a subset of AI that actually generates new content based on what it's trained on. And that's where its potential lies. I can create music. I know people have been writing poems and posting it's theirs when it actually comes from ChatGPT now. And it writes such beautiful poems, right? So music, art generation, talk about text generation, image synthesis. Gen AI has all the potential to do in this space, right? And it's backed by large language models that you keep hearing as LLMs. These are nothing but the initial base models, your GPT, your Google BERT are all foundational models that are trained on like humongous amount of data sets, right? And that's why they're able to learn from the patterns in the data set and generate new content. So just to give you an example, if you have a data set of cats and dogs and give it your traditional AI, it can say that, hey, given a new image, let me label it whether it's a cat or a dog, right? But with the Gen AI, I'm passing in the same training data set. What it will do is it will actually read, okay, you want me to generate a dog, and it will probably generate a really nice dog image for me. So that's the difference between Gen AI and traditional AI. Now, why are we speaking about this in the context of engineering effectiveness, especially how does it speed up the software delivery lifecycle, right? Just like music, just like art, it can generate code, right? Something like a GitHub Copilot is using, say, OpenAI Codex as its foundation model, trained on huge amount of public repositories with multiple programming languages. So it's able to write code, not maybe as good as you write, if you're a good developer, but it can write code, right? So at every point in the SDLC, which is right from generation of new requirements, generation of new acceptance criteria, generation of new code, generation of new tests, everywhere there is ample opportunity for Gen AI to come in and speed up. Of course, there are pitfalls that we'll talk about later, but there is a humongous opportunity there where it can speed up and bring in engineering effectiveness, additional to what Aditi and May talked about for engineering platforms and low code. Right? Yeah.
Okay. Thank you, Sowmya. Maybe we'll just stick on to this topic. And when this was high level and we introduced to engineering effectiveness, can we just go a level in detail and talk about what kind of tools and practices and techniques this approach kind of brings to the table for the developers and the team? Maybe give examples and to make them more effective and more efficient. Maybe we'll just go with the same sequence, try to make it boring. We'll just go in the same sequence. Aditi, you want to go first?
Sure. Yeah, but I mean, just going back to the ways we think about unlocking engineering effectiveness, and also thinking about, okay, how do we make our devs' life easier, right? Which is sort of the underlying theme of engineering platforms. So I mentioned earlier that as devs we spend a lot of time on a lot of things that may not be core to delivering business value, like finding information, making sure our software is secure and resilient and so on, right? But what happens in that process is that if we do not have standardization or if we do not have sort of an opinion on it, every developer or every team in an organization sort of takes a different path, right? Like I could choose to deploy my own infrastructure, or I could, decide that, okay, I'm going to get another team to deploy that for me. And similarly, as a developer on the team, I still try to understand the security practices, see if they apply to me or not, and then, make sure that it's in the pipeline. So what happens in this process is that each of us are creating our own silos, but at the same time, we are generating a lot of waste. Because what we could have leveraged by reusing what was already done and leveraging each other's best practices. So what we do in this process is that we end up generating a lot of waste, which automatically makes us feel that we are always rushing against time, right? Like we are always trying to get the feature out, or we are trying to do so many things at the same time. So to me, if you start to harness the power of engineering platforms, you will be able to minimize some of that waste, because some of that has already been automated for you. You do not have to spend your cognitive load, which is something that we've been talking about today, in trying to find that information and get a handle on that. The other aspect that we talk about, which you also see on the screen, when we are thinking about waste, there's also an opportunity for us to think about how do we build reliability and security if we are going to sort of have this engineering platform manage it for us. And like one good example that comes to my mind is because like whenever I work with teams, like almost everyone is complaining about the security hardening they have to do and how difficult the compliance and regulations are to understand. And it's only usually we have to get in a security expert or a domain expert to be able to help the developers, right? Because that's not their expertise. And one of the things that engineering platforms would try to do in this particular situation is that the compliance and security developers will publish their tooling, will publish their pipelines with all the hardening already in place because they know best, while the developer is using this applications, the product developer, and having the peace of mind that what they are building is inherently secure, right? And leaving like these security aspects to the people who know the best. So in that way, again, what engineering platform is enabling is that while I focus on feature development and product development, the other aspects that I need to worry about are sort of taken care of. And with all of these things coming together, hopefully, the developers are focused and there's lower cognitive load, and then eventually the total time to value is reduced. So that's how I would say that, the engineering platform fits together in our current sort of way of working to help us accelerate delivery. Yeah.
Thank you. It does sound like a cool gadget. May, do you want to go next?
Yeah, I think for this one, if we're thinking about how does low-code platform contribute to help engineering effectiveness in this context, I'll just try to find an example in my mind. I think one of the things are just like a concept popping into my mind is around not all low-code platforms are equal. Right, so like the example I'm actually going to use here is going to be Salesforce. So imagine your business is actually asking you to implement a sales management process. So at this time, as a developer, so normally like what we do, right, we look into just creating everything about ourselves. So basically what you come up is actually like, say, maybe a few months effort in order to create that, right? It's like your business actually start to getting frustrated, like to say, oh, I heard from other companies what they can just build this in 2 weeks time, like why can't you do this? So this one is we look into this, right? So they probably actually just talking about Salesforce, because for local platform like Salesforce, what they do, what's their key focus is really like they codified the business process as part of the like a pre-made like a key component. So what they do is around, if the requirement from your business is quite standard comparing to the industry, you are going to get huge benefits out from this, because you're just like going to just like a drag and drop. You're going to have like your sales management process probably just in 2 weeks. Yes, that's totally possible. But I think that's more like a sanity scenario for most of the cases, because quite often like your organization process is a bit of like different from what industry is there. You because it's normally like sometimes you do bake your secret sauce as part of your like business process. So that's why that actually comes to you're going to require a bit of a customization. So that actually comes to a challenge to many of the low-code platforms, because when they initially designed low-code platform, it was targeted for non-tech people. So when it coming to like a create customization, that actually really becomes challenge. So that is a space around also not only just around like a customization of the soul, but also we see some common challenges when people run into here is more like around like when you're getting started, you're quite often getting attracted by the local, very like comparing with customers code. This is very like the cost is low. But we do say if you do not utilize a local platform in the right way, you do getting trapped. You should expect a ever increasing cost. So that happens with many of organizations who adopt local platform, like expecting local, but they will just say, hey, the cost keep going up. The other one is actually the challenges the organization running into is around, they found out actually initially the speed, like to say, if I want to make any change on the platform, is getting like faster at the very beginning, but it's getting slower and slower later. What happens? So it's really because around, I can say, if you purely just thinking around like a play that like a Lego, right? Just keep piling on the changes without like a system view, without like a global view, you're going to end up like that because you can't do that. The third one is really around like quite often when you use local platform, it's not only by itself. You need to consider it's normally a key element of the entire digital ecosystem as well. So normally I think if you only focusing on like to say how do I use this local platform like itself without considering the entire value chain, the entire like a customer experience, you're going to get stuck. Especially we had some like a client within like organization actually getting stuck to say because when they design data model is they purely consider the local platform itself. They have never considered like the other downstream service which are going to consume the like a data from there, like which has caused a big trouble regarding to the overall customer experience. It's becoming a pain point there. So that's why like it's really like, yes, it will help to some extent.
Thank you, May. That's insightful. While the rapid application development, the drag and drop, while I don't enjoy that, kind of speed things up. Thanks for highlighting some of the challenges that may come across. Sowmya, do you want to just
I'll take a stab at the same principles that apply for like Gen AI can help with. So the first thing I would probably talk about is time to value, because Gen AI majorly comes in to compress the time it takes for each of the stages in the SDLC. So to give you an example, we had a project with a Chinese digital giant, and the team actually did without Gen AI and with Gen AI experiment to see how faster we were going to market. There was like a 20% productivity increase that was seen when we are going with the Gen AI tech stack that included, your ChatGPT, your Midjourney, Copilot, and so on, right? So it's estimated that as the tooling and the adoption increase, we are looking at a 2x to 3x increase in productivity. But the caveat is, if the organization isn't set up for scaling, if the operating model isn't right, if there's too much tech debt, if too much legacy architecture, your productivity gain is not going to be so high. And that, I think, ticks a lot of companies that we see, right? So majorly, time to value, it's going to be high. We can write faster code, but adding on to what Aditi was mentioning, in order to ship the code faster, it would mean that we need to invest in things like engineering platform that can help build, deploy, and test whatever code has been generated. The second is developer productivity, right? So I think many of you would have heard about this GitHub survey when it launched Copilot. It said, hey, 88% of the respondents say increase in productivity, and that's measured on two things, right? One is developer satisfaction, like I'm feeling less frustrated when I code with a Copilot. The second is, your mental energy conservation on, I'm not spending it on too many repetitive tasks. So overall, I think this Gen AI is like this robot friend to that superhero that Aditi called out, someone who can automate the repetitive tasks for you, bringing in more time to value and increasing developer productivity.
Okay, thank you. And thank you very much for showing the clock. I thought we have another 45 minutes. We'll get into the rapid fire question and answer because that was supposed to be the most interesting part, and I think we just went with the flow. We'll get into the questions, including the questions that were pre-submitted by the audience. But before I pick the audience question, I do have a question which I would like to piggyback with somebody asked from the audience to Ankit. Like, well, this cool gadget really looks cool, but I've never seen business saying that, hey, take all the money and time you want and just go do work and build something. Every time it does come with a very strict timeline and non-negotiable scope. How do you foresee, and I think I'm just piggybacking on the same question, what's your recommendation on trying to start with the engineering platform and sustaining it? What are the thoughts and some of the mental model that the organization should consider?
Sure. Yeah. Thanks, Nouman, for
and sorry, this is a rapid fire, so we just have to keep it crisp and concise.
Yep. I'll try to be as quick as I can. So yeah, I think I definitely acknowledge that engineering platform is an investment you have to make. It's not gonna be just out of your daily job or your, just the BAU that you can, build and invest an engineering platform. The other thing I would call out is that also engineering platform, because it requires that upfront investment, which I think the gentleman also called out, means that it is not something we recommend for every organization, right? It's something when you reach a particular scale, you have started to see some of the issues like, okay, developer onboarding takes 2 months, right? Or the time it takes for us to find an information is much longer. So typically we look at like an organization size of at least 150 to 200 devs or more is where an engineering platform will start to, give you the returns that you are hoping for. So I would definitely say it's something that you have to assess your maturity and then invest into. It's not, like a one size fits all when it comes to engineering platforms. Yeah.
Okay, thank you. I'm going to move on to one of the pre-submitted question, pretty straightforward and very important, is does test automation apply for low-code platform?
I think this is a great question because I think overall the principle around like everyone's familiar with concept like a testing pyramid. That still applies, right? We're basically looking to the early you test the fast feedback you're getting, so that still applies. But I think in the customized software world, we all so much getting used to doing TDD, and for every piece of code we write like a unit testing along the way. But I think looking to like a fast forward into the local platform world, what are you going to do with like 80% of the code are actually generated by like the local platform itself? Like say, like should we continue like manually write unit testing for all of this, or should we actually change like just thinking about things in a different way? It does require a bit of a like a mindset change, because like looking into, imagine if the code is generated like by the platform itself. Why can't we just have like testing generated by the the local testing automation tool as well? So we actually start to seeing the rise of the local testing automation tools as well. So basically, they are just going to focus. There's a few examples like Excel Q and Subject 7. So they are kind of like those claimed as like a local test automation tool that basically will be able to generate testing for you. They're actually with the targeting at the same audience as well. They're targeting the people who does not have like a tech background. So they don't need to write script to generate test.
Okay, and that makes sense. It's definitely a mental model shift. The test automation as a practice still applies. And I want to draw a lineage to you, Sowmya. You called out ChatGPT and it's all over. Like we saw Ghost this morning. The assistive tools kind of creating code and test. A lot of our colleagues are also started to use in Thoughtworks Copilot. And while it does generate test for you or does generate code for you, but you still need a developer to kind of look at what the tool is kind of spitting out and review it. Specifically for tests, like you still have to check if the test is all bogus or if it is testing implementation details or is it testing the right behavior of the code. What are your thoughts on So the question is that, is it really helping the developer? So at one side, it helps. The other side, it just creates more work of review and so on. What are your thoughts?
Yeah, no, absolutely right. You definitely need the developer in the loop. We haven't gotten to an extent where AI can code and test, and I would possibly I won't be here. So I think this code and test generation is like a double-edged sword, like in the sense that the more code and tests you generate, the more is the probability for that to be redundant, to be duplicate, to be not be adhering to the principles and bringing more complexity to the overall architecture. So some of the things that Thoughtworks has gone on to look at the metrics is, one, we need to have metrics to measure when we get in Gen AI. Specifically, what is your code review latency? What is your code complexity? What is your code redundancy? What is your overall system performance metric, right? And what is your architectural health like? These are very important to measure as we venture into very AI-assisted coding. And it's also seen that AI-assisted coding is less secure than when you do coding by ourselves, based on a few studies that was done last year. So it's more important that we have the right checks in place in terms of code reviews, as well as have a very comprehensive security tests and vulnerability checks running in the pipeline, so as to catch these things.
Yeah, one of the things that is also kind of coming out as a feedback is, as a developer, if the generated code and the test demands you keep on reviewing and fixing it, your development now gets converted into review and debugging, which kind of causes something called as review fatigue. Yep. And that is more challenging than actual development. It just takes away the fun, just something to be careful about. I'll pick up another question from the audience, is how do you measure engineering effectiveness? And you kind of started highlighting, maybe Aditi, you want to take this?
Sure, yeah, just in context of engineering platforms, I think as I was highlighting, right, like you need to make sure what are your bottlenecks in the organization before you start to invest in something like an engineering platform, and you set up your own platform team and start building it. So some of the measures of success that we'll usually recommend are both leading and lagging indicators. So definitely, because we are trying to optimize engineering here, DORA metrics is a big one that you should see improvement in if you have invested into the right platform and you have built it right. So especially the time it takes to get value to the market, that particular metric you should see improvement on, because now a lot of the work that the developer was supposed to do by themselves have now been offloaded. And I would also say that there are certain leading indicators, like I was saying, like when actually Spotify introduced Backstage, one of the measures they used was what is the lead time that it takes for a developer to commit their 10th PR, right? Like their 10th pull request. Because for them, that was a measure that now this developer has become effective enough in the organization to have, to be able to write code and understand their ecosystem. So there are some objective measures like this, which is like DORA metrics on the lagging side, and on the leading side, you could use, how long does it take for my developer to get onboarded? How much time are they spending finding information? Those could be two aspects. But I would also say that the platform team should also look for like subjective feedback. So go talk to your customers, developers, managers as to whether the platform is helping you, what's the net promoter score. But one of the things that we promise our clients, even when we think about engineering platform, is the net adoption rate, right? Because if you've built the platform right, you would see every developer, every team asking to get onboarded onto engineering platform. So I would say that's another metric that helps you sort of validate that what you're building is solving the need. Yeah.
Okay, I was thinking that this was an important question and we could have gone. Do you have like a 30-second version, May, for this? How in tracking and measuring the engineering effectiveness?
As soon as generally when you measure engineering effectiveness, that's like two things you measure, right? So one thing you measure like it's output. Measure the things, what do you do, how did you do things, so that's more like the specific. So actually the other measurement, you're looking around the measuring the outcome, so rather than like measuring the output. So this one, like a 4 key metrics, a bit around around the outcome, so you actually can look at the big picture rather than specific how many tests do you write and how fast can you generate code. So I tend to prefer like a measure outcome over output.
Okay, thank you. I never thought this clicking talk would be so disturbing for a moderator. We couldn't take more questions. I just wanted to quickly summarize that we've seen approaches, and the approaches has come and gone, and there's 3 approaches. I'm sure that these approaches would also evolve. You've heard about how it can help you unlock and also some of the pitfall and something to be careful about. There is also this term called as anchoring effect, which is a cognitive bias, which means that the decision of your team or your developer is influenced by an anchoring or a reference point. And if you are into an approach, that approach becomes that anchoring point and leads you, like if you're into low code, it limits and influences your decision to be in that horizon. So maybe just open up, think about the trade-off as you move into that direction. Thank you very much for being a lovely audience. Just find us around. There are a lot of other questions. If some of those were not answered, just find us around. We'll be happy to have further discussion. Thank you.
Thank you.
Thank you.